So welcome back. I know it's a bit difficult to come back, like the weather outside. So our next keynote will be given by Dr. Flavio Bonomi. He's the founder and chief technology officer at IoTSC Incorporated. He has been a Cisco fellow, vice president, and the head of the Advanced Architecture and Research Organization at Cisco Systems in San Jose, California. Co-led with J.P. Masor the vision of technology direction for Cisco Internet of Things initiative. This broad Cisco-wide initiative encompasses major verticals, including energy, connected vehicle and transportation, connected cities. In this role, with the support of his team, he is shaping a number of research and innovation efforts relating to mobility, security, communications, acceleration, distributed computing, and data management. Before joining Cisco in 1999, Flavio Bonomi was an AT&T developer between 1985 and 1995, with architecture and research responsibilities, mostly relating to the evolution of the ATM technology. And then was principal architect at two Silicon Valley startups, Zynet and Stratum. Flavio Bonomi received a Ph.D. in electrical engineering in 1985 and a Master of Electrical Engineering in 1994 from Cornell University in Italy, New York. He received his Bachelor in Electrical Engineering degree from Pavia University in Italy. Thank you very much.
Grazie, thank you. So, my CV, my bio tells you that I've been around for quite a while. And I'm an old guy, gray hair, but I had fun throughout my career, doing always what I like to do in technology with good people, discovering, opening new vistas, and following a vision. And my last years were all devoted to this great transition, which is the Internet of Things. Sorry, I have to be here. This great transition that we are all starting to touch, the Internet of Things, that brings together worlds, cultures, and incredible opportunities to help the world. Economy, agriculture, energy, a lot of the open problems, water, can be alleviated and helped through this. So I have some material here, maybe too much material as usual, and I hope I'm not going to cover what this morning speaker already covered. I know some of it will be the same. I think I have a picture that probably was presented this morning, but that's fine. And I hope I'll bring some inspiration about technologies, about trends that will carry you into your work. And we need a lot of your future interest because there's a lot of engineering to do, there's a lot of programming to do, there's a lot of participation. I think we are seeing a phase where engineering comes back. After too much hype on finance, MBAs and all that Bocconi and Wall Street and Harvard Business School, let's go back to engineering. We need to solve real problems. And there's plenty of problems to solve. So my talk will go over these items. The big hype, we are at the peak of it. And then some of the important elements of the architecture behind the solution, the end-to-end solutions for the Internet of Things. And I'll talk about some of the technologies that I care about, and I think very important that you are with me on that. Then we'll talk about a couple of verticals. I know that this meeting is about smart cities. I will touch a little bit on that topic at the end, but most of what I'm talking about is relevant because most verticals have a common architecture behind. So when we understand the architecture and the directions and the technologies, they can be applied to one or the other vertical. So there's this game of horizontal versus vertical that is intertwined and very, very important. It's a complex ecosystem. It's not easy to bring out solutions to really penetrate the right verticals because the cultures are very different. You have to learn the use cases of a certain vertical, and then you have to learn to talk the language of that vertical before you can come in with new technologies. Okay, this is the picture you saw this morning that came out a couple of months ago or a few weeks ago from Gartner. And you see that IoT got from nothing, 2010, to the top. of the hype in just 4 years. So a very fast climb, and possibly there will be a very fast descent. People will realize that it's not easy to execute, that certain verticals are difficult to penetrate, maybe even smart cities is at that level. Smart cities is coming down here because they realize, wow, they need IoT, but it's so difficult to convince the people. There's a lot of politics, there's a lot of people making decisions or not making decisions. So don't worry, we'll come down, we'll ski down the slope, and then start doing the real work. But keep going, this is not going to stop. The other very important element is a complex coming together of different cultures. These people that have built things with their yellow hats on, that have done a lot in the world of embedded systems, are now meeting the energy, the excitement of the young generations that write software quickly, sometimes not very reliably. They do social networking, and they don't speak the same language. We need to come together patiently. It's not easy, but success will come from convergence. The other thing is there's two worlds of IoT. There's one world that's very much the consumer world, the world that became very excited with the Nest acquisition, the thermostat from Google, all these bracelets that get left on the table after 2 or 3 weeks and are not very, very used. All this excitement, now we'll see the Apple iWatch coming out. We'll see how that fares. But there's a lot of excitement in the home that is really not facing the same challenges of the other world, that is the industrial world, of critical systems, in very big systems like trains, transportation, industrial automation, oil and gas. Again, two very different set of requirements, two different cultures. And IoT is both. And IoT really can benefit from the convergence of the technologies going from one to the other. And then there's this very interesting movement towards the execution of IoT. There's all the Arduino excitement, there's the crowdsourcing, crowdfunding, and a lot of environments, a lot of communities happening. Some of that will be very, very important. The maker world, very, very important for IoT because we'll need a lot of people to code, to write applications. We'll need, and I'll say that later, we'll need a new way of doing software. But this phenomenon will affect the way IoT is executed. So there's new ways away from the stodgy, slow development of large companies. And these two elements will come together. So there's a lot of interesting movements that we're already starting to witness. On the other hand, there's a number of verticals that are at the same time interested and affected by IoT. You've seen this picture, there's an eye chart, as they call it. There's a lot of spaces where you can apply IoT, and it's not clear which one will be most successful early. Sometimes one becomes exciting, like smart grid was very big for a while. Now they realize, whoa, what do we do with all these meters? Is it really happening or not? And others are coming in more slowly. I believe agriculture is very strong at this moment. So what is called precision agriculture. Industrial automation is starting to move, transportation with all the connected vehicles. But anyway, you know that there's a lot of different verticals which could be confusing. But again, if you look behind, many, many times you see some of the same elements. And in what's going on later, we will talk about this. It's important to look at the IoT as providing solutions to certain vertical problems. Vertical, I mean a certain industry. And these solutions necessarily go from the endpoints, from the sensors, from the machines, to the clouds where some of the computing will happen. There's no question that cloud computing will play a big role. So there will be end-to-end in this sense, machines, endpoints, and infrastructure in the middle, and potentially the use of computing resources all the way to the cloud. Right now, what's going on is still we have, for each industry, for each vertical, for each particular problem, we are putting down the whole infrastructure. We are connecting in certain ways to the machines. We are using certain protocols to communicate. We're using certain APIs to communicate with the applications, and all the way to the back. And this leads to a fragmented set of solutions that are not scaling well. We really need to look at the commonality. We have to look at how one infrastructure with a lot of the same functions can support multiple verticals at the same time, because we cannot afford repeating. Look at this, the case of a building, of a home. There's so many networks and so many subsystems that don't talk to each other. You can look at air conditioning. You have what? The end systems, you have the network, you have the computing, you get the video distribution, you have the lighting system. All these are separate, parallel, non-communicating systems that cost cabling, they cost resources that are not used well. And what we need to do, particularly if the smart cities is your goal, we need a common infrastructure that brings together all these use cases so that we can share, we can divide the cost across. We need to virtualize all the way through. And so that, oops, sorry, I don't want it. Okay, so we really need to learn to build things that are useful across. But when we host multiple users, multiple tenants, multiple applications on the same infrastructure, we need to protect them one against the other. So the big play will be, again, separation and virtualization over a common infrastructure. And this is what we learned from the cloud. This is what we learned from taking a computer and dividing it into virtual machines. So this is a very big topic, but it's not just computing, it's storage, it's networking, it's even the sensor access. So that you can have a sensor that is used by the guy that cares about the environment and the guy that cares about some other application. Okay, so sharing is very, very important. Okay. Now I have a set of simple graphical pictures that want to represent in a simple way the infrastructure behind IT and IoT in general. So what do we have? Right now we have all our endpoints, computers, smartphones, tablets, telephones, television, and then we connect it into a private and public network, our home, Wi-Fi, or Ethernet in the enterprise, or Internet all the way out, which brings us to local computing resources, maybe an enterprise data center, a building data center, or our home computers. Or you go out to the public clouds. There could be the cloud of your service provider, or it could be Google for searching, or it could be Facebook for your pictures. There's a lot of this going back and forth between the endpoints through the network that we take for granted, usually, except when we pay the bills for the phone bills, or all the data we do, or when we are going through Wi-Fi to the home, to the services that are out here. There's a movement from the data centers in the buildings, in the enterprises, towards the cloud. This is a very important movement that will continue. Now, what do we do? What do we see when we go into an OT environment, operations technology? This is an embedded system, an industrial automation place, a machine place. We have all these type of endpoints. We have meters, we have cameras, and so on. We have controllers that are close to the edge. And then we communicate mostly to an enterprise data center. Slowly we are moving to the cloud. But we have this kind of phenomenon down here where we have learned that we need resources. They call them PLC, controllers, that are very close to the object's control. This is where now we are coming together in IoT. This IT, information technology, is coming together with the operations technologies. And now we have many more objects, new objects connected, machine, devices, sensors, and then we still have a lot of the traditional endpoints which will be used to communicate, to control, to have a human interface to the things and to the activities around things. And then you have still the enterprise data center and the cloud behind. Many of the current applications of IoT go, you will see, straight to the back. And we need more here. You'll see what I mean. But this a current situation of the mix of IT and IoT. And here is where we want to identify a few technologies that are important in the description of what's going on. First, communication. You need to communicate in the most efficient way to these new objects down here, which may be not just little sensors, very cheap on the body or in the environment, also big machines, airplanes, cars, turbines, traffic lights, and so on. So these are the new IoT endpoints. Here we have the human interfaces. And then we go on. And we need to communicate in the most effective way, and we are not there, because many of these things are moving. The cost of this communication is very important. The power, because in some cases you need a battery down here. And you can go around and say, where did I put the sensor? Oh, it's up there. Let me take a ladder, go up and change the battery. You cannot do that. You have to put sensors with batteries that might last 10 years, 5 years in a parking lot. You cannot go there and dig it out and change the batteries. So you really need to look at what are the most effective wireless ways to communicate with sensors. And there's a lot to do in communications. You need deterministic communications if you want to control systems. So there's a lot of innovation here, and many times, and I don't know if many of you come from networking, there is a trend where they think networking is done. We have done everything, Cisco has done everything, let's move on to all this Ruby on Rails software development. That's where things happen. And we forget that networking is crucial, and is even more crucial now again. So we need to go back to networking well and continue to innovate. Second point is computing has to come back down. So we have a trend towards the clouds. All excitement is in that space. We at Cisco and others in practice, in the works of life and solving problems, realize that we need to come back down. We need more computing at the edge. We call this trend fog computing. Clouds are up far, fog is close to the ground. And there's a lot happening in that direction, and which we'll describe. That's software. And I'm not so great at software, but I realize that software is the key for the success of IoT. We need to look at software in a new way. And we are not there. The software we are using is designed for people to communicate with people. People communicating with the web. And it's not the software we need to communicate with machines. Where machines by themselves communicate with each other. There's a whole new world of software, and there's signs that that world may be at hand. And then security. Not much on that, but these are some of the key technologies we want to discuss. So a little bit on communications. I'd like to move around, but I'll stick to this microphone here for the sake of recording. So I'll try to do it from here. So first, you see here on the wireless technologies, some of the winners are starting to surface. First, Bluetooth low energy is big because it's going to be everywhere in phones. And it's a winner in the home and in many environments as a tagging of small things. The power is low, you can put batteries there, and it's available and you can interact with it through phones and other things. There's a new technology that you're probably not aware of. It's called LoRa, low power, long range, low bandwidth, that can reach kilometers in a town, in a city, and 15 more kilometers outside in open areas. And even in buildings, you can reach 600 meters. And it's very low power. You can put very long lasting batteries in. It's very low cost, and it's really the thing you want to use to tag things, to follow your dog, or to know where your luggage is, and so forth. And then we have the 15.4 IEEE 5 that is now being used in a more deterministic way that can cover some of the leftover ground. So down here, in the sensor wireless world, I see Bluetooth, IEEE 15.4, and LoRa as the winners. Above that, we'll have Wi-Fi and then 3G. Satellite is not here, it will play a big role. In fact, I'm realizing I have to put it there. Wi-Fi is moving to high bandwidth, but it has a role to play in IoT. And we already see companies here that are starting to look at that. Guglielmo, in fact, one of your hosts, is starting to move in this area. Cars are going to talk to each other through Wi-Fi. And it's a good way to aggregate wireless data that comes from below. And then, obviously, you'll have your expensive cellular communications that also has to learn to deal with small amounts of data sometimes from IoT, machine-to-machine communications. Now, when we go here to the wired space, two winners I see. Ethernet, that is always winning. Don't fight against Ethernet, you'll lose. So Ethernet is now going into the car of the future, the control networks of the future, through an evolution, you don't see it well here, towards determinism. It's called time-triggered Ethernet. There's a way to use Ethernet with precise communication of packets that arrive without jitter over the best effort traffic. And this is the future of the internal network of cars, is going to be all Ethernet. And this could be used in machines, airplanes, many other areas. But determinism will affect Wi-Fi as well, and some of the other technologies. And then we don't have to forget power line communications, which is useful when you don't need to create a new cabling in buildings, to machines, in industrial floors, and so on. You can reach them down. The refrigerator in your home, you can reach it down. So there's a lot going on there, and we are not fully there. In fact, these are the recurring themes. Time trigger, scheduling, so that you know when things will happen. Heterogeneous and mobile. You have cars in cities, trucks, airplanes, a lot, drones. Remember, drones are going to be big for IoT. Low power and low cost. So, just a set of hints, there's a lot going on in networking. Now, back to that picture. Here is where I want to talk about my favorite topic. In fact, we have been pushing this fog computing for a while. Now it's catching fire in the States. Princeton is starting a consortium on fog computing. IBM is embracing it. Intel is embracing it, and so on. Even the term. So, prepare fog computing. What is it? We've been using it. And so, let's see. Where is computing today? Computing is down everywhere. It's here in the sensor endpoints. It's in your phones. It's in the data centers of the buildings or the enterprises, and it's in the clouds. But there's a lot more that needs to be there. We need much more to support the endpoints between clouds and devices. Much more storage, much more networking. This is where fog computing comes in. Fog computing is a manifestation of cloud computing, virtualized, shared resources, but with many new connotations, particularly real-time and low power, and a lot of networking around it. In the data center is all Ethernet. Out here is all the data communication technologies that we saw before. So fog computing is that, and now you see in this picture how IoT will be supported computing-wise, from the little embedded chips in sensors to the computing in smart devices and tablets, to the gateways, to the real scalable fog nodes that could really be hardened in airplanes, trains, and other things, to the cloud. So this is the movement of computing that finds something lacking here because we've been either one end or the other. So this is the meeting place of the two worlds. And many functions happen there. Don't read these two, but there's many motivations for this new area done well, and the instruction for this. This one is not mine and my team's game. This is well embraced. So prepare for an architecture of that time, much more distributed, where these nodes may be moving with a bus, may be moving with a drone or a blimp or a tractor in the fields. A lot of data needs to be processed at the edge. Okay, so look at this. This is just interesting because it tells you big data is coming. And you see here, this is the world of today. Social networking, financial data, Twitter, 500 terabytes per day. And now comes IoT. Well, this is retail and IoT. Now you have the GE, the Boeing engines, and the high advanced physics, exabytes of it. And this stuff needs and wants to move back and forth. Data is going to be explosive. And if you don't have ways to stage the movement of data back and forth, you will not be able to do it. And if you expect all the data to be working on the cellular network of today, you're dreaming. The cellular network of today is choking of your messages and all your data and pictures and going back to Facebook. Now you bring in this stuff. Every car sending up their telematics, wanting a software update, all the machines needing to be repatched for security reasons and so on. All right, lots of stuff. And now this is an example of transportation where applications have to be distributed. There's something in the car, there's something at the roadside, in these silver boxes that you usually see, and then in the cloud. This is an example of where applications need to be distributed: parking, communication with cars, control traffic, and the smart cities will need displays to aggregate, to execute edge applications as well as cloud. And I think what Guglielmo is doing is very much in this space. I have a picture here that may be not belonging to this exact flow, but I think is a very useful picture. It comes from General Electric, and it shows where data moves and why data moves. Say, take an engine of an airplane. You need to instrument it. You need to extract and store huge amounts of data from the engine, and you need to start analyzing and transforming the data. Analyzing in the back, but analyzing also at the edge. And then you start showing it, displaying it to the people and the decision makers, and then it's shared back to people and goes back all the way to control. The intelligence flows back to control the engine, to improve its behavior, to change the situation if there's a preventive maintenance action needed. Okay, so data comes back and then controls comes forward, like that. So this flow, this virtuous flow, requires a lot of movement of data, a lot of analysis, which can be happening from the endpoint through the infrastructure and back. And here is crucial, this comment. And we are realizing how important it is, because data is generated, but data has to be made useful. So this data needs to be associated with context, with meaning, the semantics, they call it. So there's a place in between that many times happens, in fact, at the edge, where you turn these numbers into objects that can be used by the applications. That is a very crucial way. There's a place. And in fact, Dickwit from Reggio Emilia is at the forefront of this game. And it is a crucial element to really make use of all this data, because particularly when machines talk to each other, they have to know what data, what the data means, what to do with the data, how can you control a certain machine. So now, software. Where is software happening? Right now, software is running in the endpoints. Usually endpoints find a way to send it to the cloud, and then there's an exchange with your phones if you want to control the thermostat. So this is the thermostat sends it back to a cloud application running on Amazon, and then the phone finds out and you can do something. So this is the third generation of applications. It's not the ultimate way to do things. The full way will be using all the resources from the endpoints back to the fog, back to the cloud, and so forth, and even using the local data centers. So much more distributed applications than what we see now. But there will be a lot of uses that are very, very simple and useful. So this is another way to justify what's going on at the edge. At the edge, software has important roles: communications discovery, user interface, edge applications, data management and analytics, and then this abstraction of the data between things and applications. So a lot of this is a rich set of functions that may happen at the edge, need to happen at the edge more than in the back. Because once you brought your stuff all the way to the back, you consume a lot of the bandwidth. And sometimes the data is not useful. All right. I will skip forward here. So where is the software shining light? Where are the software shining lights that I see? It's in communication middleware, machine-to-machine communication services, and these are a few of the companies. This middleware, Volt Sensing is doing some of these machine-to-machine communication services. I think we have someone from Volt Sensing here, or not? Tomorrow. Sorry. Say hello to them. This is Qualcomm's pushing the standards for middleware. All join. Data adaptation. Here I do a little advertising for Dickwit from Reggio Emilia. Very fond of them. Application enablement. There's a lot of companies in the back that provide ways to mash up applications quickly that use the data you collect. Avo Data in Genova is one of the best, not very well known. ThingsWorks was sold recently for $150 million. AirCloud is from Aries. But this is very important because in the back, once you receive all the data, you can now put a map down, locate your objects, and do things. So this is the hot stuff right now in software, but it's one of the elements of the picture. And then data analytics. There's a lot going on. In fact, I'm fond of one of the first startups using the name Fog. It's called Foghorn. In California, is doing analytics, including fog and cloud. All right, many software challenges. So I want to tell you a story, but I want to skip the rest of this information. Software needs a complete revolution. You might think I'm crazy. I thought he was crazy. So this guy, Sandy, sold the company to Honeywell 26 years ago, 30 years ago. With that money, he decided, I want to start redesigning, redefining software from the bottom up. And he spent 26 years as a monk, basically, working every day on this initiative. 80,000 man-hours later, 6,000 blueprints, animation frames to prepare to give this gift to the world. Not easy to give a complete new framework, bottom up, to a world that is running 26 years ahead or aside. I believe, in the beginning I thought this guy is crazy, and now I feel more and more that there's something huge here. This work of a single-minded, concentrated person, genial person, for all these years, may bring us a complete new perspective, starting from a development environment fully graphical, a graphical programming language, no more text, particularly English-looking text, no more text. All graphics. You put together the function graphically so that you describe what you want the machine to do in a way that you can even simulate. So these are the blueprints. You design the behavior, and then the behavior maps into machine code without going through software. Software as we know. So it's really the future of reusable components, because it goes down to 64 basic components that get combined with an identification. So you know who has written that module that you're using. This is not the guy in, I don't want to say anything about Russia or Ukraine or China and so on. You want to know, when you put a piece of software, a module into your design, exactly who designed it, which entity he's belonging to, and where you want to send the money to pay for his royalties. Right now, you take code from nowhere, you attach it into your code, you don't describe it, you send it around, it becomes a black hole, you don't know security, you don't know function, and so on. So there's something coming out here. There's a new hyperprocessor that is basically the place where the virtual machines work, and that maps into the hardware. So it's like Java. Java has virtual machines way up there, and it can be ported. So here we have a new virtual machine that runs the code that has been designed graphically. And now you have a number of protocols that communicate between machines at the low level and up all the way at the web level. So maybe one day you'll say, we heard this story from Flavio. Maybe this will disappear. We don't know yet. But there's something big here. And I'll go quickly through some slides here, but just one to remember here. The design is the code. So you design this behavior, and then you distill it, not compile it. It goes to the machine without going through the traditional compilation. And the behavior is in a graphical form through flow machines and so on. It can be confusing. 26 years of work. It's taking me already 6 months to understand just a little bit. But one day this may be big. And the other thing is, everything is composable up. So you can go from a high level perspective all the way to where the data is, back and forth. So anyway, just get this seed into your mind. Let's move on. Security is another big thing. Right now, what's going on here? You have these elements. How am I doing with time, people? Fine. How much do I have?
Probably have 15 more minutes.
Very So, but I want you guys to wake up and be here and interact with me in the next. I know digestion and the sun is hot and you want to be at the beach and so on. So now security. We have all these new elements down here that sometimes are very high power, sometimes are very low power. You cannot expect functions that are very power hungry, hardware heavy, and so on, down here. The communication between the endpoints and the close to them, the close edge functions, whether it's a phone that is there or a fog computer that is local, is not that expensive. But it is not that expensive, but it can be intermittent, but it is low power. So the point is, there is a possibility to reference and to get help from nearby, whether it's a phone that you carry with you or a bigger computer that may be plugged in. So remember first this point. Second point, if you're expecting to use the cloud to authenticate everything all the time, you will require a lot of energy to go back and forth. It takes a lot of time, and many times it's not available. So similarly, you may have a bigger expense going back and forth from here as if this is isolated and intermittent. So it's very important that something happens at the edge itself in a self-reliant way. So if everything you do requires to go to a distant cloud, that's not the way for IoT. So the point is, we should do functions that are low power constrained, using elements of unclonability and trust down at the edge. So you have to do what you can there, but then rely on the edge to be your proxy, to be your helper, where you can do analytics, you can sometimes monitor the communication to the endpoint. So you go through this and say, who is the guy that wants to talk to this sensor? Who is trying to modify that machine? You may even have a virtual sensor sitting there that is the proxy where you communicate to, and then you say, okay, now I understand what you want. I will communicate with that, with the endpoints that way. So there's a role in here that could be very, very important and promising to bridge the world of embedded security and the world of IT, traditional security. That's another important thing. And then you do the big stuff in the back still. But now you can do a lot in the front that is compatible and complementary to what you do there. So there's a big point, big role for fog computing in the security space. And so here is an example of some of the functions, the way you can distribute it throughout the architecture. Encryption, lightweight, bigger, stronger encryption, compression, TPM. This has to be a trusted environment so that you can really prevent tampering and other attacks. And device authentication could be done here. This could be your reference point for authentication, patching, and so on, instead of relying on distant clouds. Again, few verticals now. I wanted to say and show you a little bit of how most verticals are really open to a common infrastructure. And in fact, some of the key building blocks apply. Transportation, automotive, industrial automation, oil and gas, and so forth. Let's look at a few. First, I'm really fond of the connected vehicle. Now we see it coming. It's still cellular only right now. But they're starting to see some Wi-Fi going into cars or the car-to-car. There's companies that are using 11P not just for car-to-car security or safety, but also for communications. And the car is becoming connected. It's a big deal now. Apple is in. Google is in, and so forth. So transportation is moving, and the internal of the car is changing. In the spirit of what we talked about, more and more computing in the car. You heard about automated drive. What is happening there? You have a lot of sensors that communicate, cameras, radar, and so forth, communicate with a more and more powerful computer inside the car. And there you have advanced algorithms to recognize objects, to recognize dangers, to help the car move. But that's a trend. There's a trend of concentration of computing out in the middle through a good network. Now the network is becoming Ethernet. So that now you have a good way to go from the sensors to the place of computing. If you trust the network, you can remove computing from the periphery and bring it one step behind. That's also a trend called software-defined machine. In industrial automation, instead of having always the control in the machine, sometimes in a very hot environment, in a difficult place, you remove it, but you have to trust the network, and you remove it to a place that is concentrated a little bit behind. Doesn't that sound like fog computing? It is the trend. Software-defined machines, GE talks about that, is the trend. And here we see it at work. In the car, instead of having all these MCUs or ECUs out here, you start virtualizing the functions into a small data center on wheels. So again, the things that we talked about are starting to happen. Software, though, is still a big problem here, and Sandy's story can apply, because now, you know what is the most expensive part of development of an automotive product? Is the software that has to be interworking in all the subsystems. Is a pain, and we need progress there. The smart cities are built around transportation. Sorry about the poor clarity of this picture, but one of the first elements in smart cities is the communication between vehicles and infrastructure. You see it here. The automation of vehicles, self-parking. There's a beautiful book. It's already a few years old, Reinventing the Automobile, by people from General Motors. And they were talking about electric, small vehicles, automated, that could self-park, that could platoon, that could move together. And so in places like this, you don't need a traffic light, because someone schedules the cars in a most effective way, and they go across each other at the same time. We're not there, don't worry. But there's a lot moving that way. There's an interaction between machine controls, parking, automation, traffic management. This is coming from world sensing. Trains are being connected and to each other, and automated trucks and satellites and so on. So very important movements in transportation based on the same architecture. Here is a picture of the industrial automation flow. Again, if you look at it, there's a pyramid that goes from the endpoints, local control, a little slower control, and so on. And this plays very well in the future of IoT here. Again, but let me skip this one more to the cities. So if you look at the cities in the same perspective, what do you have? You have endpoints and systems you want to control. You have humans that will interact with it and will interact with them through the phones and other portable things. You have an infrastructure with fog, cloud, and again, the whole story. Wireless networking, cloud, and so on. So this is, and you remember, all this should exist on the same common infrastructure, so that you don't build one for smart water, one for the lighting, one for environmental monitoring, but they all run together on a common infrastructure. Okay, so a few more thoughts in the last 5 minutes on the ecosystem. It's not easy because it's bringing together different worlds. As a startup, as an innovator, it's tough because this is a play of big people, big companies. And startups usually develop this little piece, one piece of the pie, one piece of the puzzle. And so how can we help this come together? Well, this was a network to show all the players. There's integrators. These are the ones that want the solutions. There's large companies like Google, Cisco that want to make a lot of money out of this in the middle. There's technology partners, service providers, the governments, the investors, universities. And here is the technology pioneers. I believe that from here will come a lot of innovation. These guys are very slow. They talk a lot. You probably saw a lot in the press. And they don't execute anymore. They are big sales machines. They need these guys to become big so that they can channel their products out. But this is not yet easy. They are trying to open up, but this funding has not been coming easily. These companies don't talk to the small, they are not able to absorb the small companies. They want to have complete winning companies and then they pay $3 billion. But for a small company of 20 people, $10, $20 million, they don't want to pay. So there's a little bit of a friction, let's say a little bit of friction. So, not easy. Fragmented, large company play, intellectual property plays a big role, and we need help to help the startups at the funding, but also intellectual property. So I tried to solve this problem first in a big way, failed. So, but this is an idea that will continue to live. So these are the small companies. We need to bring them together. We need to aggregate them. This is what I'm doing with a number of Italian companies, exposing them to the large strategic players, sometimes helping them to fund. When you get the funding down to them, also you can help with the intellectual property. You want to reuse innovation across verticals. So we're trying to push this, and we'll see where we're going. Conclusions. IoT is definitely hype right now, but in the long term, is the next big transition. Prepare your sons and daughters, they will work on this. This is 20 years or more of work. This is comparable to the Industrial Revolution. The impact will be huge. And it's really a revenge of engineering in that sense. There's challenges, will take time, but this is a unique inflection that can have a big impact, particularly in economies like the Italian economy. We have a lot of good industries still surviving. This technology can make them more competitive if they embrace it early. If they get stuck in their ways and they don't do it, if you guys are not participating, there's a huge opportunity lost. And I think there's a lot of technologies coming back, a lot of engineering, new architectures that can now modify the way we do IT, traditional IT, other services. The infrastructure for IoT will forge new ways of doing communication, social networking, and so forth. So this is going to be a very good back and forth experience. And again, repeating, big opportunity for the Italian industry. You need to educate, you need to celebrate professors that bring this out and teach and create these kind of conferences. Those guys will have monuments, and building dedicated to them, hopefully. But we need patience and we need stamina and we need to keep working at that. And you, as students, PhDs, researchers, don't abandon this. This is the beginning, but this is huge. Okay? All right. Any questions? Thanks.
What's the main technology provided by your company, the IoTSC?
No, IOX is a term that was used by Cisco later than when we used this IOX term. I was already out. I've been out of Cisco for 9 months now. I've been asked to go back to consult for them. So I would start when I go back. Because they are a little struggling. That IOX works was in the spirit of fog computing. IOX was using the second core, was hosting applications in edge routers, which is a good direction. This is what Guglielmo is trying to do and what needs to be done. So you need the gateways to also help applications that can help certain functions at the edge run. And you cannot just wait for the backend to do it. Good question. Yes, I'm here.
So it means that the layer you call the fog will embed something like semantic extraction from sensors and so semantic web and also agents interactions, I mean like theory methods for what concerns, for example, cars, self-guiding.
Absolutely. So the first one is the association of meaning to data. The semantic part can happen there so that you can now expose this data to applications with the meaning associated with it. Otherwise, you have to take it all the way to the back and do some of that thing. And in fact, the gateway is a good place to do that, and Liquid is trying to do it there. It makes sense. On the activity of self-guided cars, you need, for example, you go to a junction. In a junction, you have cars approaching each other. They have to communicate with each other. They have to see each other through sensors. And then the intelligence at the edge that runs in the junction should coordinate the lights, should let know one car, the other one is coming, should help coordinate the response. So, and also enable communication back and forth to the cloud through that point of communication and computing and storage. So it's very critical. It cannot be just independent cars talking to each other. We need the infrastructure. And the infrastructure has to be intelligent right there, because you cannot wait for the cloud to tell you about a second or a minute later that two cars would crash, because it would be too late. So we have another question.
Yeah, how will we create software for this fog? Or we have this whole thing, we have the cloud, we have the fog, we have the devices, and you said we have to distribute the functionality over these areas. So how we will create the software? Do we have to do it dedicated or mobile code?
Yes, so much of the software actually that can run there is the software runs on servers in the cloud. So you develop your function, you can move certain functions there. For example, in the space of network function virtualization, you can either run something in a virtual machine in the back, or you can run it in a virtual machine in the front. You have to be able to move depending on the need, depending on the connectivity. So much of it will come down from the back to the front. And so that is, we know how to develop, how to manage virtual machines and code development in the spirit of the new cloud in many ways. OpenStack will play a role. All those things that's what you want to bring. That's what you want to bring to the OT. The OT is not using that model of software development, aggregation and management, automation and so on. So that is a very good value when IT comes into OT. On the other hand, there will be new software, real-time software that needs to run there. And it's not the web traffic, the web type. This is where we need VxWorks, real-time operating systems there, so that you can respond to the interaction of cars, or you need Cubicon to do the whole thing. And that's a perfect fit. Sandy, for 6 months, Sandy, he's a marketing person. after me, and I would completely reject the mail, say, I have the infrastructure for your cloud computing. I have the software infrastructure. Please come to visit. It took me 6 months to go up to San Francisco to visit them. And then I realized, maybe they were right. The jury is still out, but we need, you can run, in fact, there, since it's the meeting place of the OT and the IT, you move some of the embedded software to run on the operating system that is real time there. And then some of the other stuff can come down from the cloud on the Linux part of the machine. So, see what I mean? So when you do control, you need something else. When you do some of the functions that we know, you know how to do them from development in the cloud. But I think, and then mobile stuff, when this is mobile now, you have to connect it the right way, tunnel the right way. There's a lot to do, but some of the elements are coming, and I'm positive it's already happening. And there was another question.
Do you think that fog computing is mandatory for the next IoT application? Because I mean, I had the opportunity to talk with several also Italian industries and customers, and they started developing application according to this approach with some, like I said, for example, in the home automation with some gateway in the home. And then, okay, when dealing with costs, they started moving towards an end-to-end solution with devices directly connected to the cloud and moving all the intelligence in the cloud. I mean, there are some vertical applications where cost is
in real time, and the data is not much. So if you have, in some cases, I give you the example of a hyperspectral imaging in agriculture. So if you're sending all the hyperspectral images back to the cloud to do analytics, you pay through your nose for the wireless connectivity, and it will take days. You need to do it there. In an oil field, you need to do it there. In the home, the question is open. If it's something that is not time sensitive, you want to send it out. But look at what you're doing at home. I don't know if you're like me. I have 2 or 3 disks for my backups. You have the Wii, the gaming machine. You have Apple TV. You have TiVo. You have the modem for the cable. You have your computer. We have, and then you have the gateway that does have a CPU. So we have all these forms of computing that you're paying. You should have one server, and then you put the game, but they don't want it.
Yeah, the problem is how to merge them because they.
Well, suppose that you have to convince Microsoft and the other guy not to sell you that box, but to give you the virtual code, virtual machine that goes into a good server. And now you can scale it. Say, oh, I need another player. Okay, it's a little difficult because there's a market. They don't want to lose their market. Apple will not give you the code for the Apple TV on the back. So commercially, it might not be easy, but there's a reason. It could be cost effective.
I see it from a technical point of view, but the problem is the commercial one, the cost point of view, and so on. From the commercial one, from the marketing point of view,
the cost.
The cost,
yeah, the cost is what you pay by having 25 different networks. When you build a house, you have the wiring for the lighting, you have the wiring for the air conditioning, you have the wiring for the cable, you have the wiring for the Ethernet, and all those things you pay for, when you could have a much more integrated system that would cost you less. But it takes time to get there. Inefficiency makes money for a lot of other people. Last question. No last question. Oh.
Do you think this kind of convergence, because it is from past even courses of Cisco, they said let's converge the voice, data, and something else together.
Voice data and video.
Yeah. To make the same network. Do you think today it can be a solution for all of kind of applications? Because as you said also, sometimes we need real operations. And for some, for something what we say, for example, let's make one processing unit for all. Sometimes we cannot use the network because of delay. If we have a delay 1 millisecond, sometimes it is so long. So what?
So in many ways, in some cases, you want to keep separate. In the car, it will take a while before they will trust the convergence. So they will have a controller for the car separate from the infotainment piece. And so, but then they will start saying, well, why can't I do it through virtualization if you trust it? Slowly things happen, in this case. In some cases, on an airplane and so on, you don't want to physically separate things. But they may look the same. See, they may use some of the same technology, but you want to separate it out because of security, because of congestion and other reasons. But it depends on how critical the system is and how much you trust. Same is happening in the cloud. Do you want to bring stuff to the cloud or not? In some cases you do. The more you trust, the more you give. All right, guys. I think we're done. Thank you.